Okay, this is the homework from Unit 4, homework number 5, graphing the linear relationships. Okay, so if I graph these 2 points, here they are, I connected the dots. I went ahead and made the equation. Oh, I think we might have done this one. Same with this one. We did this one, right? Graphed the 2 points. I figured out the slope, and I tried to estimate the equation. The y-intercept wasn't 100% accurate. Okay, next page. This is where you needed to practice. Top one, given the m and the b, the y-intercept, can I graph this line just based on the information given? So I'm starting at -1 here. My slope, notice I always write it out. My m is -3/1. Okay? So my slope is a negative line, so I know it's going downhill. The rise, in this case, starting from here, is either going to be, if I go up 3, 1, 2, 3, I go backwards 1. There's the negative. Or, again, starting from here, starting at the b is -1, I can go down 3, 1, 2, 3/1. So I have these 2 dots, put down my ruler, and I connect them. To write it in the equation form, it would be this: y equals -3x minus 1. Okay? Let's look at this one. So here's my m. My slope is 4/3. That's the rise, that's the run. It's positive, so I know the line's got to go uphill. And where's it starting? The b is 0. This is a constant proportionality. So I start at 0, and what do? I rise 4 and run 3. Rise 4. 1, 2, 3, 4. Run 3. 1, 2, 3. Put a dot. There's your line. The equation would be y equals 4/3 x. You do not need to write +0. That would be kind of foolish. Got it? Okay. Let's look at number 5. Using this equation, y equals 2x minus 1, complete the table and then graph it. All right. So, y equals 2x minus 1 is the function. It's a linear function. And they're giving me the x values that I'm feeding the machine. Okay, this is the area that you do the work for feeding the machine to figure out your y values. So this is actually the column, your x comma y, the points. Okay? So, putting a -2 into the function machine, it spits out -5. Put a -1 in there, you get -3. So your coordinate would be -1 comma -3. Put a 0 in there, and you get a -1. Put the +1 in there, it comes out to be 1, so point is 1, 1. And the last, put in a 2, and it works out to be 3. You can take all of these points, plot them in the graph, and lay the ruler down, and you have a beautiful line. Now, if you are not having fun doing the tables, you don't even have to do the tables. You can take the original equation, pick out your m, pick out your b, and just use these facts to plot the point. It started across the y-axis at -1. There it is, -1. What is its slope? It is a +2, rise over run. Oh, remember, if there's no denominator, it is always 1. Okay, the slope is just 2, so I'm rising 1, 2, and running 1. Rising 1, 2, run 1. Rising 1, 2, run 1. I got a little bit off on my line, but this is technically the shortcut method. So you got the long way, but if you have a table and you got to fill in the values, you got to do them. Okay? Or the shortcut. Just reading the equation, y equals 2x minus 1. This is your slope. This is where you start on your y-axis. Oops, sorry. This is your slope, and this is where you start on your y-axis. Okay? You will be able to graph lines in your sleep when we are done, or you better be. And if you are having trouble with this, you need to go back and redo these. This is why I'm spending the time doing this. Super, super important. All right? Okay, that's the next page. Okay. Graph these linear equations, identify the slope and the y-intercept. That's your hint. This is the shortcut page. So remember, what is the form of the equation always? Y equals mx plus b. So you can pick out your m, pick out your b. Okay, so having said that, let's look at the first one. I always write it down. Do not try to remember this stuff in your head. So your m is in front of the x. It's positive 3. I put it over 1. I write the word rise. The bottom number represents the run. The b is out here. It happens to be a negative 4. You start with the b, negative 4 on the y-axis. Put a dot at negative 4. Hold your pencil at negative 4. Count the rise and then the run. Rise 3. 1, 2, 3. Run 1. Positive. It's positive, so I know I'm running up over 1. Rise 3. 1, 2, 3. Run 1. You got enough dots. 1. 3 dots. Put your ruler down. Got your line. It doesn't get any harder than this. Okay? Let's go to number 7. What do we know? The m is this, 2/3. I write the word rise, I write the word run. So 2 represents the rise, 3 represents the run. It's a positive slope, so I know the line is definitely going in the uphill. Where is it starting? Over here at the B. The B is negative 1, and the B represents the y-axis. Okay, guys, we got to look here for the 1, negative 1, that line. Just kind of sketch it in there. Your paper might be better than mine. Okay, so at negative 1, I put a dot. This is where I'm starting. Start at negative 1, put a dot. What is my rise and my run? At negative 1, I rise 2. 1, 2. I run 3. 1, 2, 3. Put a dot. I could do the same, but it's going to go off the paper, off the grid. 1, 2, 1, 2, 3. So somewhere way out here. Okay? If I want to extend it this way, if I make both of these moves negative, it's still positive. Watch. 1, 2, that's negative. Go backwards 3. 1, 2, 3. I didn't do a good job on my line. It would be there. Okay? Direction of your line, positive, going uphill. Got it? Number 8. Same thing. Where's my slope? Right here. Negative 2 and 1 on the bottom. So I write the word rise and run next to it. What's it crossing at? The B is positive 4. Oh, right away, my slope is negative. I know this line's got to go in the downhill direction. Okay, so everybody agreed. This is uphill, this is downhill. All right, so I start at positive 4, is right here. What is my slope? Oh, negative 2. The rise is negative 2. That means go count down 2, 1, 2, but I still go over 1. Down 2, 1, 2, over 1, put the dot. Down 2, 1, 2, over 1, put the dot. Down 2, over 1, put the dot. Got it? Draw your line. Okay? Last one on the page. There's my m. M is negative 1/2 or 1 over 2. The rise is 1 or negative 1. Okay, so that's telling me then go down, right? And the run is 2. But what's my b? There is no b there, so it is understood it's 0. So I have to start this graph. This is a constant proportionality. I am starting at 0. My rise is a negative 1. Tells me go down 1. Negative 1, down 1. Run 2. 1, 2. Put a dot. Keep going. Down 1, run 2. Put a dot. Okay? Now if you went this way, I could rise 1, but I have to go backwards 2. There's your negative move. One of the moves has to be negative. And there's your line. All right? Take a good look. Okay, and the back page was old math. Okay, first one was, let's do this. If y is 7, so I take out the y and I make it a 7. And then it would equal this. 7 equals 3/2 x minus 5. I add 5 to bring the 5 over here. I get 12. 12 equals 3/2 x. Divide by 3/2. Okay, so I have x is really 12 divided by 3/2. Remember, keep, change, flip. So it would be 12 times 2/3. Simplify, and my answer is 8. So it turns out to be 8. And if you actually check this, I think it would nicely work. 7 equals, so here's my check. 7 equals 3/2 times 8 and minus 5. So let's think about this. 3/2 times 8. What do you get? That goes 4. 4 times 3 is 12 minus 5. Do we get 7? Yes. So we know it works. Okay, so x was 8. Okay, this one did not, I'm not even going to check this, but I would do this problem like the butterfly. So it is 2 times x plus 3, parentheses, and then 4 times 2x minus 1. Now you got to distribute here. So this part is 2x plus 6 equals 8x minus 4. Solve the equation by moving the 2x over, you get 6x minus 4. Okay, bring the 4 over. As a plus 4, I get 10. 10 equals 6x. So x is really 10 over 6, which is 1 4/6, which then comes out to be 1 2/3. That's fine. And last one here. All right, so if I look at this picture, something's starting at a higher number on the y, but it's decreasing over time. As time went on, this thing decreased. So get that in your head first before you start reading the bottom, okay? So think, something is decreasing as time increased. The x-axis, the bottom here, is usually time. So let's look at A. Could A be the choice? The height of a child from age 10 to 15, unless the child is shrinking, can't be that answer. The volume of a balloon as it's being filled with air, volume would increase, wouldn't it? Yeah. The amount of gasoline in a car's tank during a 5-hour trip? Is gas going to be used up in a 5-hour trip? Yes. Something's decreasing over time. There you go. And the last, the volume of water in a swimming pool as it's being filled. Wouldn't that be increasing? Yeah, so it's only C. Common sense question, but there is some math there. Okay? All right, that is the end of lesson 5. The next would be lesson 6. We'll stop here for a minute.